Hi, welcome to today's session. We are going to look at something called Canvas, and we're going to see how we can use Canvas API to use and JavaScript to kind of do some basic animation as well as drawing using that. Now, what is a Canvas or what is Canvas API? It's a way to do or draw graphics using JavaScript uh, along with HTML, right? So we use something called the Canvas element for that. And this is greatly useful for doing a lot of animation. If you're going to get into games, building games and stuff, very helpful. A lot of visualization, data visualization, photo manipulation, all of these happens on top of Canvas, and it's extremely useful on those applications. We're going to look at only 2D for now when it comes to Canvas. And the first thing you want to start by is writing a Canvas element and write an ID on it, which is canvas over here. And let's also add some width and height to it. I'm just going to add 1000 and put height also as 1000. Okay. So this will give you a basic canvas element for you. Let's go ahead and write some script here. I'm just going to write index.js and I'm going to write type text and JavaScript there. Right. I'm just going to check if this works and it's fine. So I can just say window dot add event listener, and I can just say load and write a function as a callback once the DOM content or the web window loads. So you can just check out window load event basically. This essentially is fired when the whole page has loaded. Okay, so you won't have any dependency issues, right? So let's create a basic canvas element and or fetch that element that we made. Now, when it comes to canvas, once we select this, to able to access the drawing API as such, we need to we can use the get context method within the canvas element. Okay. This you can use to basically make changes and draw on basically on your canvas. So all you would have to write is for Ctx, just writing saying context. And I'm just going to say get context in 2D. Okay. So with context now, you should be able to um, draw on top of this or use that basically. So if I wrote console log Ctx here, right, you can see the canvas rendering context 2D as well. Okay. So we can start to use this to work on top of canvas. Now, the most basic thing I can just write is I can create rectangles for this. So we can create a couple of shapes using canvas. Now, when you're working with SVG earlier, we had a lot of shapes that we got. But with canvas, we generally have only two shapes, which is a rectangle and you have paths that you can draw. Okay. So let's go create a simple fill rect here basically, and you can give some height and width to it. So I can give some value saying 100, 100. And if I just refresh, you can see that by default, it creates this black color box for you, which is 100 width and 100 height. So these are X and Y, X comma Y, and then width and height basically. So if I were to change this to 100 by 100, it will move that position in that manner. If I were to work in this manner, it will give me two of those. So if you wanted to make something like a chess game, you can actually just go create that, or a chess board, for example. You can just create that in that manner. So I can just say what equal to I less than it's an 8 by 8, so I can put in this manner and a plus plus, right? Um, and I can just say within this I need 8 So if I just wrote something like if j percentage of 2 equals to, I don't know exactly what the chessboards look like, but I'm just going to take a guess by saying that in, let's say, every even row, let's assume black and white. I just want a black and white board right now. So if it's equal to 0, and maybe you also have to check the parent one if it's even than something else, otherwise the other way around. So uh, I can just write if I percentage 2 equals to 0, then also do something. Or I can just map it together here also. And I percentage 2 equals to 0. This is assuming that we get on those lines. So we can say it's black here, right? I'm just going to say ctx dot fill rectangle, and we can define the I and j positions, right? So if I were to create a grid, I'll need to create this grid, and I need to create those boxes for me basically. So I can just do that if it's like a 2D matrix basically. You just think about it, right? And we need to have different values in it. So let's just put that this particular box needs to be, let's say, black. This needs to be white. This needs to be white. This needs to be black. Very simple logic. So one thing that you need to understand is the how do you give the positions. Now let's assume the grid size for everything is 100, right? 100 by 100 is the width and height. Okay. Now what you'll need is the starting positions for each of them. Now let's assume that we offset everything by 100, right? So it's 100 by 100 plus the position that we need. So we can probably just write var x equals to, or I can just write a separate function also for this. Function create grid, for example. Right. And I'm just gonna pass the context over there. And I'm just gonna say x equals to 100 plus. And in this case will be j into 100. And I'll say var y equals to 100 plus I into 100. So I can just put x comma y comma 100 comma 100. So if I just wrote create grid and ctx, right, we'll just get in this manner. This is basically only drawing one part for us, right? We are not getting the other part. So we'll need this also here. I can put the other condition basically. Right, so we can get in this format now, right? So this creates that grid for us. Now, if you want a different color for both, we can write in this manner. X and Y would remain the same here. It's just that the color might change. So I can say ctx dot fill style, and let's just put brown for now. Sorry, I think it's fill style equals to brown. So this is definitely changing the style. So let's put one for black here. Right. So now what happens is you're just creating a small grid and you're able to create with a simple for loop and kind of create that whole thing for you. Right. So you can just load a simple graphics by using this. right? And you can actually go ahead and create more complex things also with it. We're going to explore a few more things when you're working with Canvas. So let's try to make a small interactive app here, right? Let's take an example where we can actually uh, have a position here, and we are able to move the user from one position to the other as such, right? So the first step is we need to have a way to select a marker. Let's assume this is not set, but let's assume this is a basic grid and we are able to move this in different directions. So let's keep two positions. One is position X, and let's just put that, or I can just say player equals to pos X is 0, pos Y is 0. Now with this, we should be able to define where your position is. So I'm just going to say if pos X equals to I and pos Y equals to J, I can go ahead and draw something here. Now, to draw, you have a couple of things earlier I mentioned. One is with the rectangle. You can draw paths, and there's something called an arc also that you can draw. So what I'm going to do is I'm going to select fill style. I'm just going to say, let's take white, for example. And I can create something called a Ctx Arc. This is creating or creating a circle basically. So what it does is you can select an X or a Y coordinate. So it accepts three arguments. One is the X or Y coordinate. Third is the radii. The fourth is the start angle, right? It's a degree, start angle and the end angle. And finally, it also accepts, I think, which direction you want to go, clockwise or counterclockwise. Now let's just take, since I want this to be in the center of this to here, I can just take the value from there. Now let's take some global values. For example, let's take game settings as a object here. I can say grid height is 100, uh, grid width is, let's say, 100. So these two positions of values I can just say is game settings or grid width and grid height. I can say offset X is 0, offset Y is 0. So I can say game settings dot offset X and game settings dot offset Y. And we get that. So over here, I can just say X will be, it's basically the X we have already here. And we're going to add the grid width by 2. So I'm going to take game settings. I'm going to say grid width by 2, comma. So let's put it in as arguments here. I'm going to say Y plus game settings dot grid height by 2, right? And we can add the radius. So I can just say game settings dot grid height, one of these by 2 basically. We can play around with that also if you don't like it. We need the start and the radius or the end angle. So let's just see if this works. Now, once you create an arc, we also have to fill it. So we can just do fill here. Oops, I think seems to be something wrong there. Let me just see if there's a pos X is not defined. Yeah. So this is player.posx. This is player. Do we use that anywhere else? Okay, we need to put 360 here. And let's see if, yeah, I think we can change this to 100. Right, did something wrong here. This is wrong, I guess. So yes. Cool. So now if I put everything back to normal, it works fine. We made a small mistake here of putting I and J. So we have fixed that. And now you can see that there is a particular object over here, which basically puts that person there, right? So we can just call this a draw also if required, because we are kind of drawing this, right? And what we can also do now is to listen to these events. Now we can listen to these keyboard events in your application. So if I just put document and keyboard events over there, you can listen to some API. So we can attach something to our document itself. And let's see. Up. Right, so we can add it to our document itself. Now what we can do is document.add event listener. I can say key up, or once it loads, actually we can do it. Right, and I can say handle key up. So I can say handle key up over here. And within this, we can see some values here. So let's see, we can take the event and the key code from that. So if we take console log e.code, we'll get some information. So let's see what happens. So you can see when I use arrow left, right, you get all this information here. What happens if we attach it to the canvas instead of the document? I don't think the canvas has an event listener for that. So let's just add it to the document itself. And let's do one thing is that we'll just prevent the default behavior, right? The scroll still happens, I guess. Or you can even decide saying that, hey, I only want these events to be tracked. So I can say war events equals to, and I can say arrow left, arrow right, arrow up, arrow down as such. So I can say if e.code or events dot includes, right? And I can just search that information there. Else, if not, then I can return. So I just put console log e.code. You can see that only these 4 events are basically being tracked now. So we have the elements now. Now we can actually go ahead and decide what to do with it. So we can just say like something like, let's say a switch case. We can use a simple switch case, say e.code, right? And we can say events of 0. Or you can use a hash map also, or object here if you wish. So anyway, I'm just going to write arrow left here. I'm going to write case here, right? And we need 4 of these basically. Default, I'm just going to say now this is going to be arrow right, arrow down, arrow up. To each of them, I'm just going to also write a basic break statement also. So we have a break statement here. Now here we just need to update the position. So if I go left, I need to basically minus that. Now we'll come to the specifics of it. So I can say posx equals to, or player.posx equals to player.posx minus 1, right? And I can kind of do that similar one for each one of them. Right can basically increase it. This will be pos y. This will be pos y again, right? This is going to increase it. Now, once we do this, let's also draw the particular context again. Now, instead of putting this inside this event listener, I can put this inside the context there, and I can write in this manner. And we get a similar output. So once we do the handle key up, we can draw again. So you can see that we are getting some kind of an output. We are able to move users in different directions, but there is definitely something weird that goes on, right? So what is actually happening? So we were just facing an issue with working with Canvas. So one thing that you need to know is when you're working with Canvas arcs and paths, you always have to begin with a begin path. Okay. So when you write begin path, then your Canvas knows that it's starting at that position. Otherwise, it doesn't know, and then it causes that issue that we just saw earlier. All right. So now you can see that you're able to move between all these elements, and it draws every time that we do. So you can now also write some basic logic to basically define the outer ones. Let's, for example, if I move from left to the right side, I should move to the right end basically. So all you just need to do is saying if player.posx equals to 0, then we can say player.posx equals to let's put 8. Now we can also define the number of this as a global value also, and then kind of figure out. So grade X, let's put 8, grade Y is 8. So for both of this, you can just decide game settings dot grade X and grade Y. And we can do the same thing with here also. Game settings dot grade X here. So I can put this for each and every one of them, saying if this is equal to game settings dot grade X, then I should put 0 here. And then you can, in both cases, you can exit from this here, or you can say break here also, right? Or you can just put inside the else statement, right? If that works for you. or maybe because you want to do something else inside that, right? So if it's down, I'm just going to put game settings dot create y. Here I'm just going to put 0, and over here, let's say create y here. This works here. I think there's one, we need to -1, I guess. And let's put this as y here, and both of these should be y. Right, and this should always be -1. This should be -1 because of array indexes. So we can have now something like in this manner, right? So how do we actually get this to animate and actually like move from one position to the other position, right? So instead of actually like just using arrow key for moving individually, we can also say, hey, this is your current direction, which means you should go up, down, left, right, as such, right? So we can do it in multiple ways on how to work with this. Instead of manually using the keyboard, and we can also animate it as such. So let's make a small change, and let's write function handle direction change. Okay. We can use a similar code here, right? But we'll make a lot of changes, and make some changes for all of this. And we can just say current direction. Okay. And I can say null. Initially, it doesn't move in any direction. You can also now just go write some logic here saying that if, depending on which area you are in or which keyboard that you pressed, you can decide what direction should be. So I can say player dot current direction should be equal to something basic. So I can say left, right, down, and up. Okay. If you want to store it as a value, like for example, um, position or directions, you can also put it in this manner, right? If you want to store in a little as an enum or as a key value pair as such, both are possible. I'm just going to keep it simple for now as left, right, down, and up. Now, instead of using arrow left and all of that, I am going to change this handle key up to something else. I'm going to change, put this as direction, right? And I'm just going to say if left, right, up, down, and I say includes, right? If it doesn't include, return, else continue, right? And instead of this, I'm just going to say left. I'm going to put right, put down, and let's put up here. Okay, so we're making a small change here. Now we will, instead of the key up, we're going to put it here. So right now, what we're doing is we are handling this direction change using a separate function. And we are going to rename this as change position. Okay. So let's say I can do a set interval and I can write function and I can put every 1 minute, I can say change position, and I can say player dot current direction. Okay. So if I refresh it, and let's just put player information there. So if I refresh it and I move right, we have some issues in change position. We don't have an E. Yeah, it's E dot code. So let's put direction here and let's refresh and play that. Right. So if I actually now move, you can see that every second your position actually changes. If I move, so it's going only in a few directions, I think only up. Maybe there's a bug on that. So let's see if this is actually getting called. So I can say changing player direction, right? And I can refresh that. It seems to be everything is going in one direction, and that's because we're not breaking actually. So that's why, simple mistake. So now we can see that it's moving in the right direction, right? If I move down, it's moving down and it's going in this manner. So you can change the set interval to go at a different pace also. Right. So if you have played games like Snake, etc., all that, it may work on similar principles. But one thing is that when you're working with animation, etc., it's a little better to actually not use set interval. Okay. Um, so instead of set interval, when it comes to um, drawing as such, because we're drawing it here, instead of that, it's better to do something else. Now that's something called request animation frame. Okay. So there's something called request animation frame, which comes within the window object. So if you want to do animations, and this is probably the thing that you want to work with. Okay. This is a little better than working with set intervals because this is usually kept around 60 frames per second. This will make sure that you have a smoother animation and stuff. Okay. So uh, instead of a draw here from the change position, I am going to write a window dot request animation frame within this function draw. Okay. And now if I move, this will give you a little smoother. You might not notice it now, but this is a little more smoother when it comes to requesting animation frames. So your change position is still using a set interval because we want to control this. We want to tell that every 500 milliseconds, basically, you're changing that position. Right. So the speed is something you can control of how fast you want to update the user's information, but the animation is going to be something which is set within or set from your set intervals. The animation is something we're going to use window dot request animation frame, and we're going to call the same function within here. So at any point you want to stop this, you have a ending condition which basically ends the thing for you. So you can have an if condition saying that if stop animation, then you can just return here. That way we never reach this part, right? And that way we can stop it. Right. So far, what have we looked at? We have looked at creating a um, canvas element. We drew some basic small rectangles. We drew some grid around it. We were able to create a player with some positioning on it, and um, we were able to move the player basis this. Now you can also have more control over it. Right now you can see that the grids are limited to this, but if you want a little more smoother movement between the players also, where uh, you're not moving it from grid to grid, rather you are moving the position by some small percentage, let's say. Now that also can be done. Now it won't be in this manner. We'll have a drop player as a separate thing, right? Instead of putting inside the condition, we will have a position that we will maintain, and then we'll draw it over there, right? So this will come somewhere else. Now, even though that we were able to achieve this in Canvas, you might wonder, hey, I could have done this with SVG also. Although that is true, where Canvas is more useful is when it comes to redrawing a lot of pixel by pixel elements. Uh, it may not be very evident, but the more um, redrawing that you require on the DOM is a little more harder because Canvas doesn't have a DOM tree as such. It becomes much more effective when you have a lot more pixels that you need to work with. Okay. So the pixel oriented approach is a much more advantageous when you have like a huge number of very tiny elements. So it works with uh, when you want to work with some more smoother animations or games and you want to apply effects and all of that. So in these cases, anything that requires like a very specific pixel oriented approach, Canvas is a much better choice in that case. So let's try to also change this instead of working in this manner, right? That we are actually putting this inside a grid. I want to go ahead and make a small changes to this application. So I want to create, instead of putting this in this manner, I want to pass those values directly. So, and I want to let this be a little more smoother flowing application. This will not directly work. We need to make some changes. Okay. Now, instead of using a set interval to change the position, I am going to change the position through this here. Okay. So I am going to change the position of the player at every player position here, so that in the request animation itself, we are able to move. And what we're going to make a small change is we're going to change how we decide this. Because we don't have any more grids, right? Zero as such, we need to define our y max and our y x max. So I can say x max will be equal to, I have the information in the game settings. So I can say grid height or grid width, sorry, and the grid X is also there. And we also have the offset. So we can say grid width plus game settings dot offset X plus game settings dot we also, yeah, so instead of just this, we're going to multiply it with game settings dot number of elements in the grid. So this will give you var max, x max. I'm going to create x min equals to game settings dot offset X. Same thing I'm going to do with Y min and Y max. And I'm just going to multiply it with the grid Y there. And I'm going to say offset Y there. Now, instead of putting equal to 0, I am just going to say it should be less than X min. And I'm going to say greater than X max. I'm going to say less than Y min. And I am going to say greater than Y max. Right. And I'm just going to keep, let's say the initial one is right. I can keep the initial position as 100 and 100. Right, we get that there. So let's keep it 150 and 150. So you can see that you're able to move in this manner. So if I press up, will it come back to the normal position? It doesn't seem to be coming. So we can try debugging that as well. Yeah. So the reason is that we set it to some wrong value. So we can set it to X max, right? So if I go left, it should come from there. Now there's a small setting which is probably not right. It's not very smooth. So instead of putting less than this, I can just put plus 50 for each and every one of them. If I see this correctly now, it gives you a little more better output. And I can put the position to be also, I guess, plus 50. Let's see if that is a little more smoother. Right, so it gives you a little more cleaner intro and outro. So let's add plus 50 here. Let's add plus 50 here. Right, and this should be basically our game settings dot offset X plus, or I guess this should work. Let's see. If I move left, it comes in this manner. If I move right, it seems to be wrong. Let's start and try again. This should basically, I guess, either we should just reduce this by 50. That would be better. So if you do this now, this is a lot more cleaner now. And we can just put minus 50 there. Right. So that's a lot more cleaner. So we can work on the same way with the other ones also. So I can say offset Y minus 50. And I can say if it's going up, this should basically be Y max minus or plus 50, I guess. So if I go up, let's see up, it's less than Y min. Yeah, I think this is the case. So I can say Y max minus 50. Is for down. So sorry. When you're, let's look at up first, position minus 50 should be greater than Y max. I think this is wrong. If it's less than Y min, and this should be less than Y max. This is accurate, I guess. Yeah. So I think it works in almost all cases. Let's see if up works. Up is working here. If we go left, left is working. Right is working. So I think down may not be working. Let's see that again. Down seems to be not working. So I can just say if it's lesser than y max, we should basically come to y min minus 50, I guess. So I think this is greater than y max. If the position y plus 50 should be greater than y max, then we should do it this. That's correct. Although we are not able to see what the value is. So let's just put print our player at this point. Right, and refresh this. So we're getting up, down, similarly correct. Let's see, in this manner we get it. So let's see once more if that everything looks fine. Yeah, so I think there's a small change that may be required to just figure out this position here. So I think it's basically minus 50 here. So again, this, I think if you just try it out a couple of times, you kind of know what is happening. If you just draw out the grid sizes, you will understand what is happening. Yeah, so now we have everything working. So this basically gives us a basic idea of our how we are able to move something in a more um, smoother animation, not just like moving between grids, but we get a more a better outcome by using this. We also looked at this request animation frame, which gives us a little more smoother animation than a set interval. So this will ensure that there's a proper number of times the request is called. Now, if you want to stop this from drawing, you need to, like if you have a pause button or anything as such, then you need to have uh, uh, a breaking condition as such from this. Because if you look at it, this is kind of like a recursive call which happens. So all you do is call this and you kind of draw it for the first time, and then it keeps calling again and again. Right, so you can actually start to build more complicated gaming also, and the moment you're going to work with this, there will be a lot more uh, maths that you have to sit and figure out and apply, especially around geometry that we need to work with. But this session should give you a basic idea of how to work with Canvas and how to update the particular data points and use some, like, build a very simple interactive application using Canvas. All right. So to summarize, we can just say that we kind of looked at all the different ways we can work with Canvas. There are more things with Canvas that you want to work with. So you can definitely check out um, the Canvas tutorial from MDN itself, where it covers different parts of it. It's got a lot more things that you can work with. For example, you can use it to draw text, apply different colors on it. You can apply images on it. You can do uh, filters, etc. on that. Animations, more advanced animations also. You can also look at things like modifying the um, particular color. For example, if you want to have grayscale, inverted sepia, all of these things can be also applied onto the particular using Canvas, right? So there's a lot more things around Canvas, but again, today's session was primarily getting you introduced to the whole Canvas itself. And there are a lot of libraries that you can work along with Canvas, and some of them are mentioned here itself. P5 is a pretty common tool that is being used. There's something called Phaser also when it comes to working with games. These two are pretty common in the industry. So Phaser allows you to create actually a lot of games around JavaScript. P5 is another library for working with um, Canvas itself, right? There's an amazing set of tools that you can actually work with. So do explore Canvas later whenever you're free, but do check out the documentation for more clarity on working with Canvas.